What is IP address? IP address expands to Internet Protocol address. See, every computer or every networking device needs an IP address, correct? Now, this IP address looks like this, x dot x dot x dot x, and this x will be in the range of 0 to 255. Now, in that case, what I can tell, the minimum IP is 0.0.0.0 and maximum IP I can get is 255, 255, 255, 255. So that's the range of IP address. And IP address is made up of a 32-bit number. I can say it has 4 decimal number. As you can see below also, 4 decimal number, x dot x dot x dot x. 1 decimal is equal to 8 bits, meaning 4 8s are 32. As you can see, I said 32 number. Please write this down clearly. Write this down, guys. Thank you. Clear? So initially, when the IP address was introduced, the entire IP block was part of single network. Later on, when company divided, we broken the entire network into 5 pieces and we named them as class A, class B, class C, class D, and class E. How we are breaking? See, based on the first number. This number is there now. Based on first number value, we are telling whether it is class A, class B, class D, or class E. Imagine the first number is in the range of 0 to 127. It's called class A. If it is 128 to 191, class B. 192 to 23, class C. 224 to 239, class D. 240 to 255, class E. Okay. These are the different ranges of IP address I got. Class A, class B, D, C, and E. Now I'm going to write some IP address on screen. First I will write 11.12.13.10. Which class is this? This is class A. As you can see, 11. 11 comes under this range. So it is called class A. Now I'm going to write some IP address on my screen. You tell me which class is that. Okay. Now you guys give me the answers, everyone. Which class is there? One by. You
The
can
first one class A.
Class A,
Okay, correct. First one is
class C,
second,
class A, class B,
class B,
class C,
class C,
Class C.
class C,
class C.
C,
Okay.
C.
class D.
Okay.
No, class A.
Class A. Correct. So now easy to find out which class. It's purely based on the first value. So based on the first value, I can tell simply which class it belongs to. Now, there is a concept called subnet mask. Now, whenever you're writing an IP address in a computer, you also write a value called this 255.0.0.0. Something like this you write. You might have seen 255.0.0 or any random value you write. Now, what is the use of your subnet mask? See, your subnet mask is simply used to find out the network portion as well as host portion of an IP address. Let me give you one simple question. So if I give you an address like number 78 dot Jyoti Street, Chennai. In this, which is the house number? 78 is a house number, correct? Yes, 78. If I give some Bangalore number 87 Kalyan Street, Bangalore. This is, which is the house number? House number is 87. Okay. And street name is what? Kalyan Street. Very easy. So I can easily find out. Now, if I give you one more address, number 45, Kalyan, Kalyan Street, Bangalore. Does these two houses present in same street or different street? They are part of same street. How I am telling? Because Kalyan Street is same. Irrespective of different host names, by seeing the same street name, I can confirm they belong to same street. Similar way, in an IP address, we have network portion and host portion. Host portion meaning house number. Network portion meaning street name. So if I give you two IP address, in that network portion is same. Does that mean they belong to same LAN? Yes. One street is like one LAN. So if you imagine with the real time houses and all, here is your one street, here is one more street, here is one more street, and here is one more street. This is the main road. This is one street, this is one street, this is one street. It's like LAN 1, LAN 2, and LAN 3. And I have multiple PCs in this LAN. LAN 1, LAN 2, LAN 3. And I'm having multiple PCs in this LAN. All these PCs will have same street name or same network portion. What they will not have same is the house number. They will not have the same house number. Clear? Now, if I give you two block of IPs with same network portion, I can tell they belong to same LAN. Now, the resultant is if two PCs have same network, N1 to N1, in that case, we have to use a switch between them. And if we have network 1 connecting to network 2, we have to use a router between them. Let's see. Now, coming back to the address. Now, you guys tell me, I'm going to give you one more address. Not Indian address, some other country address. Number 34, comma, number 12, comma, number 767, comma, BLVD, Dubai. Now, you guys tell me, which is the house number and which is the street name? Or we are not sure? Please reply.
Not sure, sir.
You are not sure. Why? Because it is not following the Indian standard. They are following some other standard. I am not sure about it. What if I give you a cheat sheet for this? For example, For Indian address, cheat sheet is house number, comma, street name, comma, city, HSC, HSC. Similar way, for Dubai address, I'm giving you a cheat code called street name, house number, city name, area, and state. Now in this address, which is the house number?
12.
12. Everyone, we are 100% sure, right? No doubt in all. Without any doubt, it is 12 only. Which is the street name or street number?
34.
It's 34. And we are 100% sure about it. Now, like we have this cheat code right here. Similar way is what your subnet mask we are having. Subnet mask. Next topic. Subnet mask is used to, it is used to find out the network portion and host portion of an IP address. So 255 says represents the network portion and 0 represents the host portion. For example, if I write an IP address 10.001 255.0.0, in this network portion is 10, host portion is 0.0.1. Because like in the cheat sheet, I'm simply matching this value, place value with the given IP address, right? I'm not using any science or magic. Similar way here also, simply match 255 because 255 represents network portion, 10 became network portion, 000 host portion. So 001 became host portion. Easy. That's it. Very simply I can tell this one. Let me try one more time. 12 dot 11.23.45 255 255 255 to 0. In this network portion is what? 12 dot
1. 12.11.
11.1.23 also. Host portion is what?
45.
Correct? Easy. Now I'm going to give you some questions, everyone. Before that, if you guys have any questions, please ask me in chat. எதனா கொஸ்டின் இருந்தா கேளுங்க இப்போ ஏன்னா இப்ப நான் வந்து உங்களுக்கு I'm going to give you some content to answer now. எதுவும் கொஸ்டின் இல்லைங்களா? No questions?
No, sir.
Okay. Now the question on the screen. I want everyone to answer in the chat window. Don't tell me the answer. Just give me in chat network portion, host portion. Thank you. Please answer them now. In chat window, please enter network portion, host portion alone. I will understand for which question you are answering. No need to type your questions alone again.
Hello, sir.
Yes, tell me,
Yeah.
Sachin.
Can you please scroll a little up? Like we can note it down. Yeah, thank you.
Now, those from AWS classes. Okay. Anurag, Priya, Shashank, Shubham. Where is AWS people? Okay. So this is called one VPC, virtual private cloud. So when I say VPC, inside this I can have multiple networks. See, when I say this is network portion, this is network portion, this is host portion. In a given LAN, host network portion we cannot change, right? Meaning street name you cannot change. What you can change is your house number. By changing the house number, you end up getting multiple IPs or multiple house numbers. So this is called one VPC block. In one VPC or in Amazon's world virtual private cloud, I can have multiple blocks of IP addresses. So I can say dot one. I can vary the host portion alone multiple times. Dot two, dot three, dot four, dot five, dot six, like this all the way to dot 255. This is called one network push. Okay. Everyone clear about how to find out network portion as well as host portion. Next, we will go a step further to understand the next session called subnetting. So what is subnetting? Subnetting means breaking of one single network into multiple pieces of. Imagine that you are a big government officer. Okay. Imagine that in a country called XYZ, country name is XYZ. In that country, there were a lot of streets. Each street is having imagine each street was having 100 houses. Each street in a country or in a area was having hundreds of houses. Suddenly, the government says overnight, one street can have only 10 houses. So what you will do? And you are that minister who should take responsibility to fix the problem. Now, what you will do in this case? Can someone tell me?
Move the extra houses to the next street.
Sorry?
Move the extra houses to the next street.
How will you move the house itself? Huh?
We can allocate new houses to them, and then we can tell them to come here.
You mean demolish the existing one and build another
No,
one?
sir. We let them have the houses till that. We'll build a new one, then we'll tell them to come here.
Okay.
You have to change the street name. That what are the 10?
Break up the street into multiple smaller streets.
Okay. So what best we can do is that, right? I can give them a new street name. I can simply divide that entire street into 5 blocks, and each block I will tell you got a different street name. If I do that, ultimately we are following the rules as well as we are getting no problem. So like we are breaking the entire big street into small pieces, we do subnetting. Subnetting means breaking of one big network into small pieces, guys. So let me tell you one thing. Imagine I give an IP address 10.001.255.0.0.0. Sorry, 255.255.255.0. This means what? This means there is a network. In this network, one computer's IP is 10.001, and there are other computers also in the network. Totally, how many computers I can have? That depends on number of host bits I'm having. In this, which is the host portion? Network portion is what, first of all? 10.0.0.0. Host portion is .1.
1.
Now, how many bits are there in host portion? 8 bits.
8 bits.
Meaning
8 bits.
2 to the power of, to find out number of IPs in that block, the formula is 2 to the power of 8 or host bits minus 2. Minus 2 I am doing because
Broadcast network.
correct.
The broadcast address.
Address is termed as network ID and last address is broadcast address. 2 to the power of h means what? What is the h now? 8. 2 to the power of h means 256 minus 2 is what? 254. Two, 5, 4. Now imagine I'm getting an IP block from a manager 10.001.255.255.00. In this, how many host portions are there? Tell me someone. Find the answer and tell me.
No, sir.
16.
Huh?
16.
No, wrong.
Sir, 16.
Host portion is the number of host IPs I can get. That one. Number of IPs you can get. Number of host bits are 16. So number of host IPs 2 to the power of 16 minus 2. What I will get? 2 into 2 into 2, 16 times. 65,536 minus 2 is equal to 65,534. Now you guys tell me, is it practically possible that in one single LAN, I'm going to have 65,534 computers? Is it true?
False, sir.
We cannot have that many IPs in a one single computer network, right? It's a very big number, guys. So that is where we are doing subnetting. Subnetting means I'm going to break the entire big block of IP into small pieces. Okay. Now, it's not quite understandable or possible that I can have this many IPs in my network. Now, how can I reduce the number of IPs? That is where subnetting comes into picture. Subnetting means what? Breaking off one single network into multiple pieces. So let's break this down. We'll understand a reverse logic first of all. Why do I getting these many big numbers here? Because of this 16-bit value, right? Because this subnet mask is 255.255.00 I'm getting 16 bit as host portion. See in subnet mask, whichever numbers are 0, they are like host. And whichever numbers are 1, they are like network. Let me give one more example. 192.168.1.1, 255.255.255.0. In this, tell me network portion, host portion, number of IPs. Network portion is what? 192.
192.168.1.
Host portion is what? Dot 1. Number of host bits is how much? 8.
8 bit.
8.
Number of IPs? 2 to the power of 8
254.
minus 2. Correct, exactly. Now imagine your manager comes and tells, hey, I don't want 254 IPs. I just need 30 IPs. I don't want to waste a lot of IPs. So in that case, you decided to do subnetting. Now you will break the entire block of IP into different pieces. So before it was a very big network with 254 IP in it. Now he told 30 IPs, so I'm going to break them into 30 pieces or nearby pieces. Let's do that. To do this, it's very simple. First, you have to find out what will be the new host, how many host bits I need to find out to get 30 IPs. How many host bits I need to get approx 30. Let's see. If I give, before it was 192.168, 1.1, 255.255.255.0. Before it was 8 host bit. Now what I'm going to do? If I keep host bit as only 1, if I say host bit as 1, host bit as 2, host bit as 3. If I keep host bit as 1, how many possible IPs I can get? 2 to the power of h, this formula, number of IPs. 2 to the power of h is 1 minus 2. What you will get? 0. Now in this, 2 to the power of 2 minus 2 is equal to not possible. If I get 2 to the power of 3 minus 2, which is 4.
6.
Yeah, sorry, 8, 6, correct. 6. H is equal to 4. Yeah. 4. 2 to the power of 4 minus 2, which is 16 minus 2, 14. Not, I need 4. 2 to the power of 5. 2 to the power of 5 is what? 32. Minus 2 is equal to 30. Which means this is good. Now, I am taking only 5 host bits instead of 8. Meaning, this last portion, it is like a rubber band. If you are, it was having 8 bit in host, now I am changing to 5 bit in host. See, the last number is like a rubber band. You will, if you reduce the number of host bits now, network bit will increase. If you reduce network bit, host bit will increase. It happens like that. So in this case, I am reducing the number of host bits, meaning network bit will increase. Let's write this down in a binary format. Only that 255, 255, 255, 0. 192.168.1.1. Before it was all 0. Now we got only 5 zeros. So these 3 bits will become now part of network portion. Remaining 5 is only the host portion. Okay. Till now, is it clear? Why I marked five zeros and 3 ones here? Before we got 8 zeros. Now I need only 5 bit as first question. So I mentioned only 5 zeros instead of 8 zeros. So remaining 3 zeros will become 1 because it's like a rubber band. Okay. Now to find out the new IPs, IP blocks, you need to multiply the magic number, the last place value on ones. So here you can see this is the block I was touching on, right? The last one's place value is what? It is 128, it is 64, this one is 32. So the place value of that number is 32 and that becomes the magic number. 32 is the magic number. Now I am going to simply multiply that value by 32 to get new IP blocks. Before doing that, imagine you got one big network, one big street with 100 homes. I want to divide them into 30 pieces. Sorry, 256 homes. I want to divide them into 30 blocks. 30, 30, 30, 30, like that. First number will be what? House number 1. Last is house number 30. House number 31. House number 59. House number 60. House number 89. House number 90. Like that only I'm going to do now. So here my interesting number is 32 or magic number is 32. So first you copy this dot 0 dot 32. Just increment the IP block with 32. 64, 96, 128, 44, 2, 60, sorry, 128, 160, 160, 192, 24. That's it. I'm just adding 32 to the last number. This is the first IP on that network. Last IP will be what? 31 because 32 is here. Here, what will be the last number? 63. 64 is there. Last number 95 because 96 is here. This is called network ID. This is called broadcast ID. The first hop IP is what? 1.1. 1.30. Here first IP is what? 1.33. Last IP is what? 62. First IP is what? 65. Last IP is what? 94. So now I got 30 IPs in each block. That's it. Like this, you can fill other numbers also. This is called subnetting. Please remember that subnetting is not an easy topic to understand in one shot. If you understood, it is very good. If you're good in maths and all, but if you don't understand, that's completely fine because subnetting will take around 1 month of time to clearly go into the brain. Because I
Sir, can you explain how did you find the magic number 32?
So this is a new SM mask, right? I got 5 bit as host portion because I just need 5 bit as host to get 30 IPs. Before host was having how many bits? 8 bits.
8.
So remaining 3 will go where? It's like elastic band. If you reduce the host bit to 5, remaining 3 bit will go to the whole network portion. So it became 1111. 32 is the last one's place value, magic number. It's 128, that is 64, this is 32, right? place value. It is 1, 2, 4, 8, 16, 32. That's how I got 32.